Ok, so adesso non va perché l'ha rispenta. Okay, so unfortunately the image in the camera is dark, but this doesn't matter because basically I don't write anything on the whiteboard. I only use slides and write on this laptop, on this tablet PC. So that you can see what I write on the screen, and then I mean today's class is almost all on the slides, but if I add examples, exercises, and so on, then I can save them as a PDF file and upload it to the Virtuale platform. Okay, so there are already there is already the material of today's class and tomorrow's class on the Virtuale platform, and basically this is quite standard. So you should expect that this is what I actually am going to explain today and tomorrow. And on another thing, all of the material will be on the Virtuale platform. So, and if you to access I'm saying that for the online students, to get access to the class, just click the link in the course page. The link is called online classes, okay? And every day there will be a new class, of course. It is the virtual room for all the classes. Also, I'm going to save to record the class. I'm just recording the class now. Start recording, okay? I'm going to record the class, but I must confess I'm not sure about how to give you access to this recorded class. You may be more expert than I am, but I can record the class, and then there is a okay, there is a transcription of what I'm saying. Okay, so okay, and anyway, there is a new application which is called Panopto to manage these recorded classes. Anyway, I think that at least for 1 month to 2 months, the recorded classes will be there, so will be online. So no problem for me recording the classes. Of course, this is what I'm saying ongoing during the class. So please don't. I mean, everything is in the slides. If this is helpful for you, you can also listen to the classes again. If I create, so there is someone who's suggesting to me how to make the classes available for a longer time, I guess. But so for today, I'm just recording the class. Next, I will try to fix it. What is important is that I'm recording the classes. Now, there are a few short communications. They are quite important, however. Tomorrow I will show you also some samples of the exam, both the partial exam and the full exam. And I will add some comment on that tomorrow. Today I'm just presenting a little bit the program of the course, the material that I'm going to explain. We cannot see you on the slides, okay, because I'm not sharing the slides at the moment. I'm just, wait a moment. Okay, now I'm sharing the screen, but so far nothing was important on my screen, so okay. I'm going to show you basically the program of the course, and I do that by using the Virtuale platform and the last year's course, because more or less the program is the same. Can you see the screen? My screen?
Yes.
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 Thanks for your feedback. Okay, so basically there are two main blocks in this course. One is about functions and finding maxima and minima of functions, but not one variable functions, but multivariable functions, in particular and most often two variable function, because many models, what happens in a multivariable setting is already clear from two variable functions. We don't need to learn complicated tools for multivariable functions. And also our example will be very simple. And but before doing that, I'm going to present some preliminaries which were already in the program of the crash course, but it's very useful to present them again, also because I'm emphasizing what is really important for modeling, okay? Because 90% of the models are based on elementary functions, which means basically straight line. You may have no idea on how important is the straight line in mathematics. It's a very elementary tool, but everything is straight lines when we switch to differential calculus, because we take linear approximations of everything. Okay, so we use straight lines instead of using the true functions. Okay, at least for small changes of the variables, we use straight lines. And the derivative is based on the straight line, basically. And so the elementary functions are really important. And they are straight lines, quadratic functions, typically the parabola, power functions, which include a lot of different types of functions, in particular the square root functions and similar functions, x to the power of alpha, where alpha is an exponent between 0 and 1. Okay, because they are increasing and concave. You may already have some idea of these kind of functions. And then there are the exponential functions and the logarithmic functions. These are the really important functions. Then we will learn a little bit how to combine them, how to add constants, and just slightly modify these functions to see immediately how the graph of these new functions derived from old functions look like, okay? So this is basically what we will do initially. And then the basics on derivatives. I don't introduce the derivatives in multivariable setting based on the limits, because it's not really useful for applications. I just introduce the derivatives. You all know what the slope of a curve is, or what the slope of a surface is along some direction. I have very intuitive concepts. So I don't introduce this by the limits. And then I will show you in parallel the differentiation rules, the derivatives for one variable functions and the corresponding rule for two variable functions, which is really useful to introduce the derivatives for two variable functions, but at the same time as a refresher for the calculus for one variable function. Then I will focus on other measures of change, not just the derivative, other measures of change that are even more useful for application, the differential, the relative rate of change, or logarithmic derivative, and the elasticity. They are other measures of change, strongly related to the concept of derivative, but at the same time they have a different meaning. And then something about the second derivatives, how to look at second derivatives in a multivariable setting, how to check the concavity of a function or the convexity of a function in simple cases. And this is what I call quadratic approximation of a function. Okay, so quadratic functions are parabolas, when we use quadratic approximations, we approximate functions with parabolas or surfaces that are like similar to parabolas in a multivariable setting. Then I will show you again that this is the derivatives and the differentiation for multivariable functions. Something initially about the matrix notation and matrix products, because it is useful to study multivariable functions. And then I will show you three main applications actually. One is the implicit functions, and it is computing the derivatives along a so-called level curve of a multivariable, two-variable function, which is something related to one variable functions, but it can be done using two variable functions, okay? Then I will show you how to maximize or minimize a function without constraints, which is unconstrained optimization. Then I will show you, most important in economics, where always constraints are always present, okay? Constrained optimizations and examples. And then review exercises on the first part of the course, of course. And this ends the first part of the course, and this will be the material, basically, the material of the midterm exam. Possibly, it depends on the, not all years are the same, but it depends on the time, available time. Possibly, there will be also this part on elementary rules of indefinite integration. Just because indefinite integration is just the inverse operation of differentiation, okay? So just finding the functions, knowing the derivative, by knowing the derivative, going backward. So possibly this first part will be in the first, will be part of the program of the first midterm exam. In the second part is devoted to dynamics from different viewpoints, okay? This includes definite integral, because definite integral is very useful when we want to look at the time interval in a dynamic setting, okay? And try to understand what is the behavior of trajectory of some variable by knowing what happens in a short period of time. So we will use integrals mostly for this kind of application, okay? Definite integrals, and you see already here another application is discounting in continuous time, which is so important in economics, where we must make decisions over for a time interval that goes from now to the future, some point in the future, maybe to plus infinity, okay? And we need to aggregate the profits or the utilities corresponding to each small time interval. We have to aggregate all of them in some index, some value today, okay? This is called present value computations in continuous time or discounting in continuous time. This is also part of the financial mathematics, but it is very often used in economics when optimizing in continuous time. Then I will show you how to apply derivatives and integrals to dynamical systems in continuous time. This is basically called first order differential equations. You know that some variable evolves in a short period of time according to a certain law. For instance, the increment is proportional to the level already reached by the variable at the beginning of the period. This is the simplest model. Then you want to see what happens in the long run. Okay? So solving a differential equation. So I will show you some simple examples, including linear and separable. And then I will show you basically something also in discrete times. The discrete time equivalent of differential equations are called difference equations. So here we don't use derivatives, we don't use integrals, but here we use basically geometric sums. Series in general, but geometric sums in our example. Then I will show you some essentials of matrix algebra, and the goal of this part is not to be able to solve complicated problems in matrix algebra. is just to show you basically the notation and the basic structures. For instance, if I multiply a matrix by a vector of a certain dimension, apart from the result of the product, what is important is also that you have what the structure of the result, have in mind what the structure of the result is. Is the result a vector? Which kind of object is the result? A vector, a matrix, a scalar? Scalar is a number. Okay? So if I see a quadratic form can be expressed as a product of matrices. It is so important in econometrics, for instance, that you must know that a quadratic form is in fact a scalar. Okay? So you multiply matrices and vectors, but the result is a number. Okay? So having structures in mind means that the exercises, I will show you the examples tomorrow from the exam sample exam paper. What is important is understanding the structure of the result. Okay. Also keep in mind that there will be different ways to solve these kind of problems. If you know a little bit of theory behind matrices, you can find at least 2 different ways to solve every exercise. Then I will show you eigenvalues and eigenvectors, which belong to matrix algebra, but have as their main application dynamical systems, not dynamic equations, but systems of equations. Okay? So I show you some simple example in 2 variables, okay? Differential equation systems, and a typical property of the solution of dynamical systems in 2 variables in economics. This is a typical property in economics, which is called saddle path stability. And I will use this saddle path stability to show you basically how we can solve graphically a simple, 2 simple problems of dynamic optimization in continuous time. Okay, so this is basically what I'm going to do. So, of course, the material is a lot, but in fact, I will focus on the main concepts, the main structures, the main ideas, and the main applications and models for each topic. Okay? An implication of this, I'm not sure whether you should be happy or sad about that, but an implication is that the theory is not, theory means theorems, proper definition, rigorous definitions of quantities, of properties, and proofs are not part of the final examination. But in fact, theory is implicitly part of the final examination, because if you don't know the theory and you know only one way to solve an exercise, you cannot check the solution to that exercise in a different way. Okay? For instance, this is an example. And also theory is important because if you know a little bit about the theory, you know also how to solve the exercises. What is the strategy to solve an exercise. Okay, so I hope that for the moment everything is clear. About the examinations, there will be a midterm exam in November. I'm not sure about the dates, precise dates of the exam, and whether they are official or not. Not yet official, I don't know. Anyway, it is in November during the break. Then there is another exam date in January, and then another in January, end of January or February. So 2 winter, the first of which can be split in 2 parts. Okay? 2 winter exam dates, but the first one can be split in 2 parts. So you can choose whether to split it in midterm exam plus final exam in January on the second part, or just take the final exam in January, full exam. Okay? This is for the first exam day. This is not official, but it's really useful to students, also because we only have 3 different exams, only 3 exam sessions during the year, not many. Okay? You are allowed to complete the midterm exam, not only in the first exam date in January, but also in February. Okay, so you can choose, you have a wide range of strategies. Full exam in January or full exam in February. Or midterm exam in November and finish it in January by taking the second part in January. Or midterm exam in November and finish it in February. Of course, not both. Not both. You have to select one of them. And also, if you don't pass the exam at the end of the second part, or if you are not happy with the result and you want to reject it, you cannot, you have to repeat the whole exam, the full exam, okay? If you reject the grade, even if the exam was split in two parts, you reject the full grade. So you have to take the full exam in another date, okay? Is that clear? Everything clear? Also for students at home, is everything clear about the exams?
Yeah.
Yes, Professor.
Yes, thanks.
Okay, so a lot of possibilities, and my experience is that this way, I mean, students can plan their work over the months after the course, okay, so quite well. So this is basically what I wanted to show. Now, another thing, maybe I will show you some examples later. A very useful way to check your, to support your study of this subject in a traditional way is to use some tool to see immediately what the result is of a problem. For instance, one very popular is GeoGebra, which is very powerful, but what I really like is this one. It's called Desmos. You may know it already. Nobody knows it? It's, I mean, it's very, very useful, I'm not sure it is very popular, but it is very useful. And you can do a lot of things with this, maybe not computing, I mean, not solving systems of differential equations at the end of the course, but one variable functions, implicit functions, and many problems in two variables that imply a solution that lies at the tangent